So welcome to Broadcast Show. I've got Mike Leach again with me from Workstation Specialists. We've covered a few areas of building the perfect digital video workstation with Mike, and we've covered CPU, we've covered memory, and we've covered graphics card, and today is storage. Storage, yes. Tell us a little bit about storage.
Well, storage, hard drives, typically sort of the bane of most people's lives, I suppose, with just file sizes getting bigger and bigger. It's just how you should configure your storage in your workstation and basically giving it the best effect and the best performance. So it's all designed really, we would always recommend around the types of file you work with. So typically everyone's working with HD, larger, stereo, 2K, maybe even 4K. And obviously as the file sizes increase, so there's the capacity of storage drives that you need, and obviously the speed of the drives. Now there's typically probably 4 main types of technology. Start off with SSD, and that's one type of technology. We've got the SATA technology, which runs at 7,200 RPM. We have the SATA technology that runs at 10,000 RPM, and then SAS, which is serial attached SCSI, which are available with 10, 15, and 7,500 RPM. So there's 4 different types of technology, all completely different, all designed for different types of workflows. And when it comes to digital video, it's typically all about that capacity versus performance sort of sweet spot. So depending on how you use the software, depending on where you're working with uncompressed, various different codecs, obviously your file size is important, but obviously the speed of the hard drive. So what we've got here, I say, is 2 similar systems that we've been using in the last couple of weeks. It's just, this one's configured with a single standard hard drive, normal 7,200 RPM vanilla hard drive. I'm working with 1080p 8-bit standard video. We're seeing a read and write speed of about 150 megabytes per second. And then this one's configured with what's called a RAID configuration, which is, RAID stands for Redundant Array of Independent Disks. So we're using, on this machine, 2 hard drives joined together in RAID 0, which is called striping, and it's literally giving us over twice the performance. So for read-write speed on the same type of data, the speed of this drive configuration is twice as fast.
So by configuring it as RAID 0, why is it that much quicker?
Well, basically you've got 2 physical drives, so you're reading and writing to both drives at the same time, and your data is basically split half onto one drive, half onto the other. So essentially they're performing twice as fast. You could use the RAID standard, RAID 0, and use 4 drives and see that speed double again. You can go from 4 to 8 drives and see that double again. So typically RAID 0 is raw performance increase, and literally then the more drives you have in that array, the faster the speeds. We do drive configurations with RAID supporting sort of upwards of 16 drives. Now we can do 3,000, 4,000 megabytes per second, so you can basically work with uncompressed to 4K video without any problems whatsoever. But obviously it's all about price, capacity, performance. You never really hold your entire portfolio of products on the one workstation, so obviously it's typically you would have the configuration designed to suit your current project needs.
And it's obviously important to mention with RAID 0 that you back up everything.
Yes, I mean, RAID, there's different sorts of RAID, 0, 1, 3, 5, 10, 6, there's 20 or 30 different versions. RAID 0 is all about performance. So basically, there's no redundancy. If any one hard disk fails, you lose your entire contents. If you had something like RAID 1, which is the same 2 drives, but they're mirrored together. So if you write one onto the hard disk, it's mirrored onto the second drive, but you see no performance gain. And there's various versions of something like RAID 5, which gives you performance and redundancy in the same array. So you get the performance benefits of striping, not so much the full 100%, but maybe sort of 80% of the speed. But you've got the ability then that if one drive was to fail, you haven't lost all your data. So, and again, there's different configurations to suit different sorts of workflow. You could spend all day configuring a RAID card, but what we would do is we'd request information on how you plan to use the workstation, the size, complexity of projects you work with, types of bit rates and compressions you work with, and then we would configure a workstation designed for that with obviously headroom to grow.
Got you. Now you mentioned different types of storage.
Yes.
These we're looking at, are they spinning disks?
Yeah, these are the standard platter 7,200 RPM drives. The faster the rotation speed, the faster, obviously the faster the speed, but you also get a shorter latency, so the drives work faster. The technology called SSD, solid state drives, which is probably sort of a buzzword, I suppose, everyone's sort of talking about now at the moment. They're not platter rotating, it's basically sort of NAND flash RAM on a drive, so there's no physical moving parts, they're much quicker to access, much quicker read and write speeds, but the capacities are typically smaller. So a modern workstation today would have a solid state drive for its boot, its Windows, its operating system drive. That's where you install your Adobe packages and everything else. but you then pair that with a RAID configuration of platter drives for your data storage. You can do RAID configurations on SSD to get really insane performance speed increases, but the capacity is quite small and the price is typically very high.
A big wallet.
Yeah, so depending on whether you work with sort of, if you want to have a media cache drive, so you might be streaming stuff on and off, then we could do 3 types of drive: SSD for boot, SSD caching for video, and then a raw platter-based drive for secondary storage.
Gotcha. So if somebody just went out and bought an SSD, I mean, all SSDs are the same on?
No, I mean, saying yes, SSD, no 2 SSDs are kind of the same. So this is a reasonable test we've got here. So we're just swapping over now on both these systems from the storage drive to the C drive. Now, the machine on the right has a fairly standard sort of, sort of a cheaper sort of SSD drive. It's still SSD. If we run the same tests again here, we're getting a read and write speed about 150 megabytes for the write, about 240 for the read, but it's having that consistent. So if we were to run that again for 3 times, we're getting a reasonably consistent, but the read speed is considerably higher than the write speed. If we did the same one here on a much faster drive, we can see the read speed is almost sort of 50% faster. So booting from that, loading the applications much quicker, and if we increase the file size, again, we can see a fairly sort of steady increase. If we increase the file size on here, obviously the speed increase, then it does have an impact on the drive's overall performance. But this is a much faster type of SSD, and we can do SSDs that have almost equal read and write speeds if required.
So depending on how you're going to use it.
I mean, this is just a boot drive, so it's all about the read. It's not really about the write, because you're writing data to your storage drive. But if you were writing to that for storage, then we would configure a type of SSD that's built for writing as well.
Gotcha. Mike, that's great. Thank you. If you've got questions about anything to do with storage and how to spec up the system, then obviously you can talk to Mike and his team. You will find their details on the website link, which is just about here. And obviously you can tweet them as well, which is at W Specialists. So catch them on Twitter as well. We're going to be doing one more video with Mike from Workstation Specialists. We're going to do a little bit of speed testing between these machines overall to see how they perform. You can find that on the feed when it comes up, which is at broadcastshow.com/live, and of course everything else we're doing will be there as well. So we look forward to seeing you on the next broadcast show.